Okay, I guess we can start. Can you all hear me all right? Okay. Sorry a little bit about my voice. I've been under the weather the past couple of days, but I should be able to pull through. Thank you so much for coming to this talk. Thank you so much. Of course, before we begin, let me say just a couple of words about myself. I'm part of a company called New Venture Software. The interesting thing about this company is that it was founded by 4 ex-Telerik guys. So it's really an honor and very exciting for me to be here, seeing so many friends and ex-colleagues. We specialize in providing software consulting and software development services. And of course, we do a lot of things with Azure, whether that's deploying customer projects on Azure, using it for our development productivity, or just experimenting with new and exciting stuff. I'm also teaching Azure at the American University in Bulgaria. All right, so that's enough for an introduction. What I intend to cover today is I think it's always good to start with some context. So we'll trace the evolution of the cloud and how we ended up here having this serverless thing. And we'll compare it to the other solutions or cloud services out there, how it can benefit us. Of course, the focus of this talk will be Azure Functions. All right, of course, we have a couple of live demos. So I hope that the demo gods are with us. If there's time at the end, we can have a Q&A session. But of course, after the presentation, anyone is welcome to come and have a chat. Okay? Okay, so a little bit about the evolution of the cloud. And as you know, of course, everything starts with on-premises, where we have a machine, a box that runs our application or our service that we're providing to our users. And in this case, we all have to worry about many, many things that are not necessarily providing business value. For example, we have to worry about networking. How am I updating or upgrading the operating system? What happens if a hard drive fails, for example? All right, stuff like that, that's not so interesting, maybe if you're developing an application. And the cloud really exploded with this next thing called infrastructure as a service. Okay, this is basically you renting a virtual machine or a box somewhere, so you don't have the physical thing in your building or somewhere in your room. That's a little bit better, of course. We don't have to worry about how this box is wired to the internet, things like that, but we still have to think about how we are upgrading our operating system. Okay? How can I keep my service running if I need to do a OS update? Okay? Now, many people actually consider this next step, the platform as a service, as the first big breakthrough of the cloud providers, where the cloud provider said, okay, let's actually take care of this operating thing. And you just have your data in an application, you upload it somewhere, and you run it for you. And we take care of patching the operating system, the networking, things like that. But still, we had to think about, okay, I have this app now running in the cloud. How can I actually scale it? You had to think about infrastructure. Also, you had to think like what kind of tier I need to purchase of this platform as a service, whatever it is. And this is how we actually arrive at the next evolution. This is pretty much the pinnacle right now of the cloud services out there. And the basic premise is, okay, let's reduce this worry about infrastructure to a minimum. Let the cloud provider handle operating system upgrades. Let them handle this scaling automatically. So you just have your code, it's running, and you only think about your code. All right? Now, serverless is a little bit of a funny term, actually, because serverless involves a lot of servers. But the basic premise is you don't have to think about those servers. There are servers somewhere in the cloud, but you do not worry about them. Okay? Okay, so now let's take a look at the major features. I just mentioned that there are servers that are running your code, but you do not think about those. Also, you get this automatic, and many people start calling it infinite scale. Of course, there's some limit there. But your application or code is supposed to handle any load that you can throw at it. And the last point, I think it's very important, is the billing process. I think this is the major driving force. That would be the major driving force for many companies for embracing serverless. The idea here is that you're only paying for the time that your code runs. All right? Instead of having a virtual machine somewhere that is sitting all day and just waiting for a single request or something to be done for 1 minute or 1 hour each day. Okay, so you're only paying for the time that you're using the resources. Of course, the benefits, we obviously have reduced DevOps. Probably administrators are not too happy with that, but okay. We can focus on the business. We can focus more on delivering our applications, and as a result, of course, faster time to market. Now, serverless is not a single thing. It actually involves several components that often go together. So first, when we're doing serverless, we're pushed towards this notion of building application components. We don't have one huge thing, but rather we're thinking in terms of loosely coupled code that runs independently, that's deployed independently. Now, of course, once we have those components, they have to somehow talk to each other. So we have those messaging. Those components are messaging themselves somehow. There are a lot of frameworks out there. And of course, we have the data. Every application is using data. So those are the three main components that you have to worry about, of course, when doing serverless. And let me now compare serverless to the more traditional approach, the monolith approach. I'm not going to bash monolith here. It has its place. I just wanted to compare it to this new paradigm and how it's different. Now, when you're having a monolith, you might have, let's say, ASP.NET, some kind of system that is deployed as one thing. And if you need to change, let's say, this thing over here, you change it in, you again have to deploy the whole thing. Also, what happens is this thing that I've just circled out requires a lot, all of a sudden wants more resources, let's say more computing power. Okay, you have to scale the whole thing in order to satisfy the requirements of your some sort of piece of code here in the monolith. Okay. And again, I mentioned this with the serverless approach, we're more leaning towards components, where each component is developed and deployed separately. This gives us a great benefit. And one of the benefits is that now that I have this isolated thing, this silo, we can very easily silence it. Oh, sorry, scale it. All right. Just to reiterate, with the components, of course, there's a need to some kind of messaging systems. And there are many, many messaging systems out there on Azure. We can use Azure Storage queues, Azure Service Bus, or the new kit on the block called Event Grid to send and pass messages. Now, today, we're not going to spend too much time talking about those, but you just have to keep those in mind. We need to use messaging system. And the other important thing is serverless, again, as I mentioned, it's not a one thing. You need to have different components. You need to have the messaging. You need to have to be able to run your code in the cloud. And of course, you need access to database. So you might need access to analytics. And Azure provides all of that. It has all of the infrastructure that you would need to go serverless. And now let's think about scenarios where, let's say, serverless shines. One scenario is time-based processing. Whenever something needs to happen on a schedule, For example, at night at 1 p.m., you might be pruning your database. That's perfect for serverless, because you will only be paying for the amount of time that your code is executed or is running. Any real-time processing of data, you might be ingesting a lot of real-time data and just want to massage it some way, to transform it. You can have a function that transforms this data and later on saves it to some kind of storage, an SQL or whatever you choose. Mobile backends. If you're building a social application or social some kind of web app, doesn't matter. You probably don't want random grandmothers uploading 10 megabytes worth of pictures of cats. Okay, you probably don't want to do that. Those cats, of course. What you probably want to do is whenever someone uploads an image, you might want to run some code that resizes this image and saves it again. All right, so you're using your space more efficiently. And the other thing, we can easily integrate with other external systems. Whenever something happens, run this code, which will produce some output. Okay, so any scenario where we have events is very good for serverless. So quick summary here. Serverless, supposed to, shouldn't worry about infrastructure so much. It's a event-driven approach to creating systems. We pay only for what we're using. And of course, Azure provides all the tools that we need. Now moving on to Azure Functions. Now what is Azure Functions? In a nutshell, Azure Functions is a platform for running code in the cloud. It's simple as that. Of course, it provides many other things, but its main purpose is of Azure Functions is for you to upload your code there, and it will run on some server. Okay? Quickly going to go through the main features, other features of Azure Functions. You can choose your own language or platform that you can develop your systems or application with. The runtime is built in such a way that in theory it can support any language out there. Currently we can use C#, JavaScript. Java is in preview and soon will be available. We also have JavaScript. You can use scripting languages like PHP, PowerShell, Bash, Batch. I think that's pretty good coverage there. Flexible development. That's one of the things that I really like about Azure Functions is that you can just go to the portal, create an Azure function, and start coding right away. So you can do it using the web tools, which of course are very good for poking around and experimenting at the start. But after that, you can use, of course, Visual Studio Code, or any other tool that you might like. Of course, you get this automatic scale, pay-per-use model. Azure Functions is built on the Azure App Service. More on that a little bit later. And it's open source. Actually, you can go and see how the runtime is implemented. You can contribute, and of course, you can make extension points if there is a need. You can create triggers and bindings. More on this, of course, later. Now here's a slide with a lot of rectangles. Okay, so the most important thing here on this slide is that we're building upon an already existing ecosystem that's tried and tested. Just mentioned that Azure Functions is built on top of Azure App Service, meaning that you automatically get continuous integration. You get deployment slots. What this means is that you can have a staging environment where you test your Azure Functions, and whenever you're sure that they're all right, you can flip them to production. You get remote debugging and other of the features pretty much of the Azure App Service. And Azure Functions, if anyone has dealt with web jobs, Azure Functions is built on top of those as well. Okay, so let's switch to our first demo. Let's take a look at how we can create Azure Functions and dig a little bit deeper. All right, so this is the Azure portal. If you haven't used it, this is the web app that allows you to create Azure resources. So this is what I'm going to do now. I'm going to add a new resource. Hopefully we have internet. OK, that's good. And I'm just going to search for function. And what you want to create is this so-called, function app here. Okay. You just have to come up with some kind of name. All right. Actually, that had happened many times to me. I mean, go figure. OK, let's try again. OK, that's good. OK. That was scripted, actually. Of course not. Now, I'm not going to talk about the other options. The defaults are just fine. What you would like to have is this consumption plan, and you just go ahead and create this function app. Okay. Now, this will take about 2-3 minutes, so let's not waste 2 and 3 minutes and just jump in another application that I've already created. Sorry, let's go full screen. Sorry about that. So once your function is created, you can navigate to it, and you're taken to something like a dashboard. Important thing here is on the left side. Here are our functions. Now, you can think of the function app as a container of our code, of the different functions that we create. Okay? And of course, this is empty now, and let's create our first function. Now, there's a good wizard-like experience where you can point to the scenarios that you're interested in, but let's go ahead and create custom functions because I want to show you the different templates. Now, templates can be used as a starting point, and they're based on scenarios that you want to cover. Are you actually seeing this all right? Is it good? OK, thank you. So let's say that I want to create a function with C#, and I want to create, let's say, some kind of an API. Okay, so basically, I'm filtering the different templates here. Zoom in a little bit. All right. So I have a couple of things here, and let's choose HTTP trigger. Now, triggers is a fundamental concept in Azure Functions. The trigger specifies how and when your function is executed. So in this case, our function will be executed by an HTTP request. Okay, so we're basically building a web API or something like that, some kind of a web API. Okay, we choose a name. The default one is just fine. We click create. Okay, and we see some boilerplate code here. Let's take this junk for a second. Okay, and take a look. Now, if you're developing user C#, you see that that's actually pretty standard C# function. It's an async. It returns something. It accepts some parameters. So that's pretty fine. Okay, it's pretty standard. So let's unpack this. Now, the first parameter is actually data of our trigger. Many times, whenever the triggers actually contain some data. Now, since we're building this web API, and we're triggered by an HTTP request, this request might contain some data, some JSON, or something else that we want to work with. So that's this first parameter, and the value of this request will contain the JSON and whatever we sent using the request. We have this trace thing here. It's automatic. If you include it in the signature of your function, it's so automatically injected by the framework, and you basically use it to log stuff. Not very exciting. And we also have some output. Since we are doing web API, whenever there's a request, it's a good thing to have, of course, a response. Right? Now, to show you this, we can actually demonstrate in here. There's a built-in tool for testing inside this web environment, but let's use Postman. Okay. So here at the top, okay, let me just show it here. Here at the top, you can get the link to your function, the URL. And if I open Postman, post my Oops, not this one. Yeah, basically copied the whole site. Anyway. And let's say that I want to do a post request to this function. Okay, there it is. And let's say I want to have some JSON payload. Okay. Again, see, that's it. And if I send a request, I should get a response. And of course, I have this response. Okay, so that's very basic functions. We're just responding to some HTTP requests. Now, of course, you can have logic here to process some entities or return something, of course, more meaningful. I just want to show you the experience using another language. So JavaScript is very hip right now. So let's do JavaScript as well. Do the same thing with JavaScript and see how it looks like. All right, so JavaScript, HTTP trigger. Again, creating my function. Okay, just to show you that it's the same thing. Nah, there's a copy button here anyway. Okay, just going to replace this URL here. Send a request, and I get the same thing back, basically the same thing. But now we're using JavaScript. Now the difference here, of course, the environment is a little bit different. Our main function, we need to assign it to the exports, of course. Again, we are getting the request, the data of the request here in the request parameter. Also, there's this thing context. Now we use the context to specify when the function is done executed, using done here. And we also use the context to return, to provide this response that we want to give to the user. Now let's talk a little bit about those. Now, how does the environment actually know that it should return the contents of this thing here, this object, and then creating and assigning to the field res as a response? What will happen if I do this? Of course, it won't work. And it's a really nice segue to talking about the other important feature, actually, building block, or rather, of Azure Functions. And these are the so-called bindings. Let's take a look at the bindings. Here we have the files of our app. And there's this function JS thing. Now, this contains the bindings, and the bindings are actually a declarative way of specifying how our function is triggered, and also the inputs and outputs, or the data that our function ingests and generates. So if we take a look at the first item here, this thing is of type HTTP trigger. Also, the direction is in. And we have a name. Okay, so this is the name of the parameter in our code. So this is how the runtime knows, okay, I have to map the incoming request of its data to this parameter here. The other thing also that's interesting is the output parameter. This, again, is of type HTTP, meaning you will be using request to responses. The direction is out. And we have this name here, res. All right, and this is how the runtime knows that this will be the output that we want to provide to our users. Now, this is very powerful, and we'll see it in the other demo later on. But the idea with this declarative approach is that you don't have to think, for example, if you want to save an item to a database as a result of some Azure function, you don't have to think about how you're actually connecting to this database. You don't have to think about connection strings. You just pass in this data, create it in a similar fashion, and the underlying framework will take care of this. Now, here we're just providing something that we're returning to the user, but as you know, HTTP responses are not only constructed of a body and a status. You might have content types and other things associated to it. So it's a bigger thing. So here, what the binding will do is just get this information here and transform it into a full-blown request for you. You don't have to create it yourself. And as I mentioned, we'll later on see how this is really helpful when we're building something real. Okay. And the other cool thing about this environment is that I can very easily, of course, change code here if I want to experiment, let's say. And if I hit this, yeah, I should get an error. Right? So it's very cool for experimenting. Let's go back to the presentation. Yeah, something that I forgot. Just a second. I wanted to show you the other triggers that we can have, the other templates. So again, let's say we want JavaScript. We have a timer trigger. So this is a template for functions that run on a schedule. For example, every day, every other day, twice a day, etc. We can have a function that is triggered based on a message arriving at a queue, whenever someone saves something on a blob, and many other scenarios. We can also trigger our functions based on a generic webhook, and many other. Again, if there is a trigger that you need, you can write it yourself, no problem. Trigger or binding, okay? But that's rarely actually the case, so yeah. Just a summary. Whenever we're creating a function, we have a trigger, something that invokes our function. We can have, of course, one trigger per function. And this trigger can have some kind of data associated with it, and we can very easily access this data. Bindings, this is the declarative approach to connecting to data. We can have multiple bindings. They are optional, but usually have multiple bindings per function. And here, this is a list of the functions, but okay. All right, so now let's think about a more realistic example. Of course, we did something like an API. Of course, it was a dummy function. Let's think about something real, how Azure Functions can help us in a real situation. Let's think about a conference management system. Let's say we're building such a web system where owners or creators of conferences like DevReach can sign up and manage their conferences. Okay. Let's say that we have this system right now, which is a web app. You can go there, create your conference, stuff like that. But let's also say that we want to introduce a new module to our system. Let's say that we want to have something like a reporting. Our users want to actually have a reporting on all of the tweets happening for a specific, related to a specific conference. And what they want to have as an option is to have some kind of analytics service running that gets the sentiment of each tweet, meaning if the tweet is positive or it's negative. Okay? And yeah, of course, there's no problem to build this reporting functionality right into our monolith. We can have some kind of backend API that ingests tweets somehow, analyzes those tweets, analyzes the sentiment, and writes those to the database. That's fairly fine. But actually, can you handle 100 tweets per second? Can you handle 10,000 tweets per second with this approach? Yeah, maybe you can. But just because now your reporting module wants more processing power, you have to scale your whole application. Furthermore, you can actually be DDoSing your own web application when your service is running on the same hardware and the same monolith system. Because if you're trying to process 10,000 tweets per second, maybe your web app will be unresponsive, depending on your server, of course, but that might be the case. Now, what if we take the other approach? What if we take this reporting service, which seems like a pretty isolated thing, and move it off to Azure Functions? Okay? So let's do this now. So yeah, it seems a really good candidate for that. And another point I would like to make is that actually this is a really good example of how you can introduce serverless to your systems very easily. If you're having a monolith system, you can just pull one thing, one isolated thing out, and make it into a serverless component. There's no need for you to break the whole thing from the beginning. All right? So let me just show you this application real quick first, if I can find it. Okay, there it is. This is the conf Genie. So application, of course, demo app. Let's say that we are managing DevReach conference. We've got the previous conferences here, and we want to. Oh, sorry. Thank you. Yeah, that also happens. Thank you. Okay, so that's the demo app. So we've got several previous conferences. We have the DevReach 2017, and let's say we want to see the report. And if we go to the report, we will actually see all the tweets in relation to DevReach, having the DevReach tag thing, not DevReach 2007. In this instance, it's only the DevReach tag. And actually, this app has been running for the past 2 days. So it's pretty much processed all the tweets. And as you can see here, we can see the author, we can see the tweet itself, and this sentiment calculated. If the tweet is positive, if it's 1, it's most positive. If it's towards 0, it's really negative. And of course, we have some icon on that. And of course, we can navigate to the tweets. Okay, so let's say that that's what our customers want. How can we implement it using Azure Functions? All right, so now I'm going to switch gears a bit. Do you prefer the white theme or the dark theme? Do you have any preference? What looks best? Dark one? Okay, all right. Okay, let's do that. Okay. Now I've decided to implement this using Java, the JavaScript Azure function, and this time I'm going to show you how more realistic dev environment would look like. Okay, so this is my function. Of course, there has some more code here. The first difference is, as you compare it to the sample function that we've seen previously, is of course that I'm using some NPM modules. No problem for that. I want to use promises if I need to generate some unique GUIDs, or use moment.js to handle dates better. And here I also have my function that is processing all of the tweets. Now what this tweets does, of course, we have our context, which we use to specify when we are done executing. And we have, of course, the original request. Now assume that the original request contains all the Twitter information, like the text, the author, and the link. Of course, there's no error checking here for the sake of brevity. Okay. And so what this function does is it requests a sentiment. I'm using the Azure Cognitive Services. I think there was a presentation, or there will be, about cognitive services. Of course, you can switch that with your own algorithm or whatever. Requesting a sentiment, whenever I get a sentiment, I prepare some data that will be saved to my database. Okay, and I'm using a binding for this. More on that in just a second. And yeah, once I'm done, specify that I'm done. Of course, I handle the error case. If there's an error, I'll log it and say that I'm done. Now, I mentioned that once we process the data, we're going to save it currently in a table storage, but doesn't matter. Do you see any code about connecting to databases here? No, right? This is where the power of bindings comes in. If we switch to the function JSON where our bindings are defined. This new thing about the writing data to a database is here. Now, this binding is a built-in binding of type table, meaning that the data will be saved to Azure Table Storage. This is simple NoSQL storage on Azure. We'll be using the table name tweets and connection string conference storage. And this is only a reference to a connection string. All right, and also the name of the binding is tweet entry. This is where I'm providing the data, the field of the data that needs to be saved. So that's it. No connecting to databases, no more like leaving your connection string in the source code. I'm sure that there's some guys scanning GitHub, collecting connection strings from databases. Okay. Now, the best thing about this is, of course, the development. We usually want to develop on our own machines. We don't want to upload code on the cloud and test it. Of course, that's slow. What we can do is we can run a simulation environment here code that will simulate our function running in the cloud, but it will be running locally on our local host. The next good thing is that I can actually attach. And if I go again to Postman and say the sample request, okay, there it is. So we have our local host. Now our application, Azure function is called tweet sentiment, and it expects this data here: text, author, link, and published on. Of course, this is some dummy data. And if I click send, I can actually debug the request, step over, check what's going on, and debug it. And this is actually the data that will be sent and saved to the database. All right. Okay. Now again, just to summarize what we're doing here, we're creating currently some kind of an API that can get Twitter data, transform it in a way that we want to, get the sentiment about the Twitter text, and save it to a database. Now with the same tools, once I'm ready, I can easily upload this function to the cloud. Again, I've already done this, and let me. Now, actually, if you this function, this is running live. So if you tweet something with a DevReach tag, it should appear here. So if you want to test it, you can, no problem. Let me just. This is my function app. And once you upload your function from your local development environment, you, of course, see it here. Here's the tweet sentiment, and I can now edit it live in the portal if I need to, of course. Okay. So we are doing pretty good on time. Are there any questions currently with this approach, or? All right. Okay, so let's jump in back to the presentation. So what we've achieved with this approach are several things. First of all, our reporting thing, that's getting tweet data and analyzing it, is running an independent module. It has automatic scale that we'll talk about in a second, meaning that in theory, no matter how much demand there is or how much request you throw at this function in the cloud, Azure should be able to scale and handle the load. No matter if it's 1 tweet per second, if it's 10,000 tweets per second, you get, of course, the idea. Of course, there are some limits. I mean, yeah, more of that you can find more on the limits on the documentation. And also, we've written this using JavaScript. And our main application in the backend is written in C#. So Also, this is a nice way to experiment with other technologies. And the two things are completely decoupled. Also, our web app is in no way affected by the reporting module. If it fails, if there are errors, there's no way for our app to fail. Okay? Now about scaling. How does the runtime and the system scale? Now, it really depends on the triggers, but there's this thing called the scale controller, which is listening to all of the events that are triggering your function and looking at how many instances you have already running. So if you, for example, have many requests coming in and the one instance of your function that's running in the cloud cannot cope with it, it will automatically introduce another instance and another instance and another instance. This is very dependent on the trigger that you have. So if you have a queue, the scale controller will look at the queue length. And if the queue length is already increasing, that's a signal that probably, okay, let's introduce another instance. And so the scale controller will try to balance those things out. Okay, now the billing model. Of course, that's very important for everybody. You want to be happy. As I mentioned in the beginning, the whole premise is that for many scenarios, you should be paying a lot less. In some scenarios, you can reduce your cost many times. Now, for Azure Functions, you're built on number of executions. If your function runs one time, that's one execution. And also on the amount of resources that your functions have consumed. There's a funky metric called gigabyte seconds, meaning how many gigabytes you're using per second. Now that's very fuzzy. You can look it up at this link here, the price calculator. But let's quickly take a look at one example, just to put things into perspective. Now let's say that you have a function that has run 3 million times. That's quite a lot. And each time it ran for 1 second. And for each of those executions, your function used 520 megabytes. That is also a lot. At the end of the day, you will pay around $17. Okay? So this is how the price is calculated. Now, the next thing that I would like to show is called Logic Apps. Now, Logic Apps and Function Apps are best buddies, usually are used together. And you might be wondering, okay, we have created an API that can scale and can process tweet data, but actually, where is the tweet data coming from? How are we listening for tweet events? Okay, where do we get this information? Okay. Of course, I used here Logic Apps. So let me again go to the portal. Into my Logic App. Now, Logic Apps, they can be used to create very sophisticated workflows. Whenever something happens, do that. If that happens, do that. So it's really fascinating piece of technology. Let me just show you the designer. Now, in our case, this is really simple, but yet powerful. Now, Logic Apps are very similar to Function Apps in that they have a trigger. Something is triggering your Logic App. And in this case, I have a trigger when a new tweet is posted. So whenever a tweet is posted on Twitter, we can process it. And of course, here, for the demo, I'm filtering by tag. So whenever we have a Twitter message with DevReach tag, we're going to process it. And our workflow, so once that function is triggered, we can go to the next step. And the next step is actually invocation of our function app that we've just created, and where we're just building the body of the request using the data coming in from Twitter. So we're passing in the author. Of course, we're generating here the link and also the test. All right, so this is how this thing is working. Let's check on the app to see if somebody has posted something. No. You guys, you should have posted something. All right. Good job. Good job. Okay, that's great. Okay, the application works, so yeah, everybody's happy. Thank you so much. All right. All right, so that's Logic Apps. Now about the tooling. So words about tooling. We've already seen that we can develop using the web interface. We can just go to the portal and develop our apps. We can, of course, use Visual Studio. You can use Visual Studio Code. And the central tool for doing that, for developing locally, is this tool called Azure Functions Core Tools. You can check it out. It's an NPM module which you install. This version currently only works on Windows, but the one that's in development, the Core Tools, works everywhere. Okay. So you just install it. It allows you to create new Azure functions. If I go back to Visual Studio Code, where that is. Okay, there it is. Each function is a separate folder, so whenever you use the tool, it will create this folder for you, and all of the files that you need, it will create the function JSON, and depending on the template that you choose, it will create a template. For example, for this, I started off with the HTTP trigger template, and then modified it according to my needs. Okay, yeah, if you would like to check out Azure Functions, you can follow those links. And of course, you can also try the Azure App Service. Now, if you would like to learn more about Azure in general, you can check out our Azure user group Bulgaria, where we meet each month to discuss various topics on Azure. You can poke us. Now, of course, there's some time for questions if you have any questions. If not, I can show you some additional things. Okay, are there any questions?
Can you have multiple triggers on one function?
No, it's only one trigger. Okay, do you have some kind of scenario that you want to discuss, or just?
If you want to do something on multiple occasions. For example, you can do it if you receive a query message, but then you want to request on demand.
No, yeah, currently you can only have one trigger, but that example, maybe that scenario is maybe better covered with, let's say, Logic Apps. Okay, okay.
Thanks.
Yeah.
When
Yeah, go ahead.
So when auto-scaling, can we have some access to the load balancers?
No, currently everything is automatic. You don't have access. That's the whole premise, that you shouldn't care.
But I somehow lose the priority of my loads.
Yes, you do. I think there might be introducing some way to do that, but currently no. Yeah. Also, the thing about this, having this controller transparently there working, is that I'm sure, maybe they're doing it now, but at least in the future they'll sure run some machine learning on it. And if your app is scaling on some kind of pattern, this thing will know that, let's say on March 2019, I should prefer more resources for you or something like that. Okay, but now.
Tell me the feature in your Your code.
Yeah. Okay.
Sell me your product.
Sorry?
Sell me your product.
What do you mean my product?
Okay, this product.
You can try it for yourself. I'm not selling anything. I'm just sharing experience here and how you can do stuff.
I just want to take the best features and concise them into one sentence.
The Azure app thing. For me, it's the thing is that you can really easily get started with this web approach. Actually, when I was teaching with the students my Azure course at the university, several years ago, we didn't have this Azure thing, and I wanted to teach them about how they can upload code in the cloud that runs independently, and then we had only web jobs. And it was very difficult because you had to know about many things, how to do that. You had to upload it. It was difficult to debug. Very, very bad experience, developer experience. Now this thing, as you saw with this simple several clicks, you can go ahead and figure things out, start poking around, and decide whether you can use it. Okay, and of course, and the price should be a factor as well. Okay, yeah.
So, I got a question to the pricing. One of our problems is when we are trying to sell some Azure features or to provide some Azure features to the customer, we have to get an estimation of how this thing will actually cost. And the Azure Functions itself, they got a lot of free stuff, a lot of free executions. I already checked this in the price calculator. And the additional resources will then rise the costs. Did I understand it right?
Yeah, of course. I mean, yeah, if you have a lot of things to process, yeah, of course you will be paying because yeah.
Let's say I'm making an Azure Web Service, okay?
Mm-hmm.
And this app service will then call the HTTP trigger when this is going to be executed or whatever. This Azure App Service will be necessary to actually call to execute the function, and this will also provide the costs, right?
Mm-hmm. Yes.
Same thing is if I'm doing the messaging queue and so on and so on. So I have to do an analysis what kind of features are actually needed, and are they always on full costs, or how do I get a good estimation for that? You get it?
Yeah, I do get it. Well, yeah, that's an interesting question. Of course, you can base your assumptions, calculations on some assumptions and adjust as you move along. I mean, there's no, I think, perfect answer for that right now. Okay.
Hopefully the pricing calculator will give you the answer.
Yeah. Mm-hmm.
Thank you.
Okay. Any other questions? Yeah.
Can you show us how, after development of the solution, you can upload it and how you actually proceed with testing the staging environments?
Yeah, sure. So one way that you can do it is with this tool, okay, which is running here. So you can have a script, but that's probably not the. I'm just going to show you this approach. Of course, once you install the tools, you have this function, which you can have called different. For example, Azure, func Azure, and we can function app. It's a little bit convoluted, but anyway, function app, and you can go ahead and publish everything that I have in the current directory. So that's one way to publish. Now, another way that you can do it is if you go to your app. Okay. You can go to your app. Let's see, because I haven't done this. Deployment options. Okay. Now, what I can configure, maybe I've clicked too fast here. Let me just back up. Okay. So here you have those called deployment options, and this is part of the app service environment. You go to deployment options. setup. And here you can automatically choose the source control that you would like to use. There's a built-in, of course, support for team services, for OneDrive, so you can be basically just getting some files. Of course, you can have a local Git repository, you can have GitHub, Bitbucket, Dropbox, or external repository. So what you can do is have your files sitting on Git. You can have some more sophisticated thing. For example, the build process, actually, once it gets your files, this is built in. It's called kudu, actually. To get your files, you can run scripts to, for example, you have TypeScript or need to perform some kind of processing of your files, compilations or whatnot. You can compile them. You can run tests on your functions, for example. And then this thing will be uploaded as the latest version. All right. And let's back up here again. And you have those slots here. Okay, this is preview. Okay, I have to enable this feature. So basically, once you enable this feature, you can have many slots. For example, you can have testing, staging, and you can instruct this process. After the build process, you can deploy first to your staging environment. And once it's there in the staging environment and you're ready with it, you just click a button, flip a switch, and it will become the new production thing. If you need more advanced project, you can use Visual Studio Team Services. If you need something, of course, more involved and sophisticated. Does this answer the question? All right. Any other questions? Yeah.
What about unit testing? How does that work with?
Yeah. I've kind of mentioned this. So let's say that we have, let's go back to the code. Here, and this is our function. There's no problem for me to introduce some tests. And of course, those tests should run somewhere. First, you can have your own environment to run those tests and then upload to functions. You can use this kudu, which to some extent, this automatic built-in process built into the app service, which is to some extent limited. But you can have tests run there. So you do not need to worry about infrastructure. So you write your test. There's a really good documentation on this. Okay, and your test can be running. If there are no failures, this will be automatically accepted as the latest version. Again, you can use Visual Studio Team Services. You can have whatever tool you would like to use, because you can use whatever other build server out there. You can run your test and then call specific Azure services to upload your code after the tests have passed or something like that. Does this kind of answer it? All right. The one thing that you should remember is your Azure functions are just files, those files. Okay, so you can have those files delivered to Azure in a number of ways. You can deliver them using, for example, FTP. So you can have a process on some machine somewhere that getting latest, for example, for Git, running your server, running tests on some kind of server. This is and then after that, you can upload the output of your build process using FTP. Of course, I mean, yeah, well, that's an option. Nobody will probably do that, but of course you have it. You can use the tools here that I've demonstrated. For example, you can use this tool to actually upload your app. You can use this Git integration inside the app service environment, and you can use something that's totally external to upload files. All right. Any other question, guys? Okay, so right on time. Again, if you have any other questions, you can come to me. I'll be glad to discuss anything with you. Thank you so much for attending this talk. Thank you.